So the method we want to use to actually test for absolute and conditional convergence is actually how we actually find our final interval of convergence, which we have to take into account our endpoints. So if we're asked to find an interval of convergence, we have to worry about should the endpoints be part of it as well, which is a very common mistake, that people just stop at doing a ratio test and never check the endpoints. So to do this, we start with the ratio test, and that gives us what I call the preliminary interval of convergence, in that I'm saying I know for between the endpoints this is going to work. It's going to converge. But then we have to check the endpoints. And the way we do that is we plug in each endpoint for x, which will give us two different series that we will then check to see, does each of those series converge? If it does, then we include it in the interval. If it doesn't, then it's not part of our interval. These are going to be places where typically we're going to see conditional convergence, even with alternating series. This is where conditional convergence usually happens. So, for example, here, let's look at the series 1 to infinity of -1 to n plus 1, which tells me it's alternating, x to 2n over 2n. So, to find the interval of convergence, I start with the ratio test, because that's our only test that will find a interval of convergence for us. So I'm going to be doing the limit, and goes to infinity of the n plus absolute value of the n plus first term. Now notice, because I'm doing this absolutely, I don't need the alternating part, because it doesn't matter what -1 to any power is. The absolute value makes that 1. So the n plus first term divided by my nth term, and I get the limit as n goes to infinity of the absolute value of x squared times 2n over 2n plus 2. Well, the 2n, the x squared is not affected by my limit. The 2n over 2n plus 2, that's infinity over infinity. I can do L'Hopital's rule. I can do n behavior model. By the way, this becomes 1, and this is going to equal the absolute value of x squared. Well, to converge, I know the absolute value of x squared has to be less than 1, which means that x is going to be between -1 and 1. So this is my preliminary interval. It's not my final answer, because I need to check the endpoint. So to check the endpoints, I pick one of the endpoints to start with, and let's say 1, x equals 1. I plug this in for x. I have a series, and goes from 1 to infinity, -1 to the n plus 1, times 1 to the 2n over 2n. Well, that's the same as saying series from 1 to infinity of -1 to the n plus 1 times 1/2, or sorry, 1 over 2n. There are several ways I could do this one. I could do alternating series test, because it is an alternating one. So if I do the alternating series test, so alternating series test, it is alternating. 1 over 2n is always positive, and 1 over 2n is decreasing. And my limit as n approaches infinity of 1 over 2n is 0. So this does converge. Now, I don't know if it's converging absolutely or conditionally. Well, I know. It's not, I haven't showed it's converging absolutely. So at a minimum, this is conditional. To check if that's absolute, if I look at the series from n equals 1 to infinity, absolute value means I don't need the alternating part, so it's 1 over 2n. I could use limit comparison. or sorry, not limit comparison. This is really, I have a 1/2 I could take out of this. So this would be 1/2 times the sum from 1 to infinity of 1 over n. And this, by p-series test, I know diverges. So it does converge conditionally at 1, but it does converge. So my interval now is from -1 up to and including +1. So that was one of my endpoints. So plugging in that. Well, -1 to the 2n means I'm doing -1 to an even power, which means that this will always equal 1. So I now have that this is a series 1 to infinity, -1 to the n plus 1 times 1 over 2n, which is the exact same series I already checked for x equals +1. So I know that this converges conditionally. And if you're curious about that, just look at my work up above for when x would equal to +1. So I now have my final interval of convergence is from -1 to 1 and including my endpoints. If I asked about absolute convergence, that's from -1 to 1. It does not include the endpoints. And then finally, if I'm asked where's conditional convergence, well, that was just at my endpoints of -1 and 1.